Welcome everyone for this session. In this session, we will deal about triple integrals. Using this triple integral, how we can find the center of mass, centroid, moments about x-axis, moment about y-axis, and moment about z-axis of a solid body. So, just we can brush up our previous class. Previous class, we have seen triple integral as a Riemann sum. Definition of triple integration, theorem relating triple integral, and triple integral over general bounded regions in space, and how we can calculate the triple integrals. So today we are going to deal about volume, mass, center of mass, and moment of inertia. So the volume is given as triple integral over T dV, and mass, center of mass, and moment of inertia of the bodies are given by the formula. This mass is given by the triple integral over T. Mass is given as triple integral over T of density function into dV, right? Then the moments about x-axis, we will write it as myz. So moment about x-axis myz equal to triple integral over T x into rho xyz dV. Previously it was in double integral, it was in x rho xy dx dy, right? It is in triple integral case. Double integral case. Now in triple integral means again x is there, then rho is going to be a function of z also. Next is coming dz. Only this is the difference. Now moment about y-axis, we will write it as mxz, that's equal to triple integral over T y rho xyz dV. Now the moment about z-axis, we will write it as mxy, and that is equal to triple integral over T z into rho xyz dV. So let us see, using this formula, how we can calculate the mass and moments, and next is going to be center of mass, right? So we can calculate center of mass using this formula, m by mx, m by my, m by mz. Like that we can calculate it. Okay, see here, center of mass T is located at the point x bar, y bar, z bar, where x bar equal to this is moment about x-axis by mass, moment about y-axis by mass, and z bar equal to moment about this right. So moment about z-axis by m is coming, and moment of inertia is given to be as moment of inertia with respect to x-axis equal to triple integral over T y square plus z square rho xyz dV. This is moment of inertia about x-axis. Now about y-axis, previously it was with respect to y, x means y square into this is coming. Now here moment of inertia about y is equal to triple integral over T x square plus z square into rho xyz dV, and with respect to z means triple integral over T x square plus y square. See, this is alternative, cyclically changing, right? So with respect to x means no x term, right? So with respect to y, no y term. With respect to z, here is no z term. Okay, so this is a formula. So whenever the mass density is constant, then the center of mass of a solid is called a centroid of T. So in some point they will ask to find centroid. In that case, you note that the density is a constant. So let us see how we can work out with this formula. Example 4. Let T be a solid tetrahedron bounded by the plane x plus y plus z equal to 1, and the three coordinate planes x equal to 0, y equal to 0, and z equal to 0. That means our coordinate axis. Find the mass of T if the mass density of T is directly proportional to the distance between the base of T and a point on T. So the similar problem we have done in your double integration case. That case we have got the function as k times the distance, right? So in this case it's directly proportional, so k times r squared, something like that is coming there. So here let us see how we can take it. The solid T is shown in figure. See, tetrahedron is shown in figure. It is X, Y and Z symbol, right? Each side is coming. For example, it can be viewed as being X symbol if you observe that it is bounded by the surface Z equal to K1, X equal to K1 YZ equal to 0 and the surface X equal to K2 YZ equal to 1 minus Y minus Z. This surface and this surface. Okay. Now solve the equation x plus y plus z equal to 1 for x. What you're getting is x equal to 1 minus y minus z. So we have taken that only the limit. Right. Now its projection when you are taking in your yz plane. See this one. YZ plane, you will get exactly a rectangle like this. Exactly a triangle like this. And this triangle, your Z is varying from 0 to 1 minus Y. Right? 0 to 1 minus Y. And your Y is varying from 0 to 1. So we can go for integration with this limit. So writing this as rho xyz dv is equal to kz into dv, because the distance I have taken as z, right? Now k into integral 0 to 1, integral 0 to 1 minus y, integral 0 to z value is 1 minus y minus z into z dx dz dy. Now as before, when you are calculating triple integral, we can easily calculate this value. So only thing is that we should identify what is the limit and in which manner we are taking it, whether it's x symbol or y symbol or z symbol. Only that thing we have to note here. So like in example 5, let T be a solid that is bounded by the parabolic cylinder. So a parabolic cylinder, because cross section could be a parabola, something like that. Cylinder y equal to x square and the plane z equal to 0 and y plus z equal to 1. Find the center of mass of T given that it is a uniform density, right? So it will become center of itself, constant one, right? So how we can solve it? So given that z is varying from 0 to y plus z plus, so you can take z as 1 minus y, right? So 1 minus y, then we can consider is if you're taking z axis, then we can consider its cross section or projection in xy plane. In xy plane it is given something like this, right? So here you can see that your y is varying from this here to here. That means this point is going to be y equal to x square it is. So x square to 1 it is moving and your x value is lying between minus 1 to 1. So the limit should be, for x it should be minus 1 to 1. For y it should be, I should take the other way, right? Okay, y is, this is for x. Now this for y. For y it should be from x square to 1, and for z it should be, z is varying from 0 to 1 minus y, right? So let us see whether they are giving the limit like this. See, z equal to 0 to z equal to 1 minus y, and your y varying from x square to 1 and x varying from minus 1 to 1. So we have calculated all the limit correctly, right? And just we are finding this is going to be 8 by 15. Now by symmetry we have seen that x bar equal to 0, right? Because see, x is symmetric, so x bar somewhere here only it will lie. So his x coordinate should be 0. Now we want to find what is your y coordinate. So y bar equal to 1 by m into, we are having y bar is equal to m xz by m, right? So and what is mxz? Mxz means triple integral over t y into rho xyz dv. So we are finding that here. So rho y, this we have calculated as like this. So m is 8 by 15. So 1 by m become 15 by 8 into y into rho xyz will become, what is rho xyz? It's of uniform thing, right? So we will get y into dv. So just we are finding the limit as such. Z, this is for y and this is for x. So we will have this equal to 3 by 7. And similarly we want to find z bar, and z bar also we will get it as like this. Next example is, find the moment of inertia about the 3 coordinate axes for the solid rectangular parallelepiped of constant density k. So using equation we will get rho xyz equal to k, and we will obtain ix equal to triple integral over t y square plus z square into k dv. So we want to give its limit. So since it's giving like this, you can see that your x value, this is the x-axis, so x is varying from this point to this point, right? That's from 0 here, so this is minus a to a, and y is ranging from, this is y now, y is ranging from minus b to b, and this c is ranging from where to where? Minus c to c. So you can easily have this like this. Of the entire length is a, means it should be a by 2, and this also a by 2. Since entire length is b, this is b by 2, and this also b by 2, since we are taking from 0, right? So this value c by 2 will come. So we can easily calculate what's coming here, k into x square plus z square dx dy. Now we can calculate ix, iy and iz very easily. So what's the formula for calculating? That is, see here, moment about x means y square plus z square into k into dv, because k is given to be as the density function. General formula is ix equal to triple integral over t of y square plus z square into, if it's with respect to x, y square plus z square into rho of xyz into dx dy dz. So since here rho xyz is a constant, we can easily calculate what is this integral is coming, right? So hope you understood how we have calculated this. Only thing is that here's we want to KABC is coming. So ABC means volume, right? ABC means volume. Now K means density. K equal to density. We know that mass by volume is equal to density, right? So volume into density means it should be mass. So M equal to KAB will represent mass. So we can replace that with M into B square plus C square. So this is where moment of inertia about x-axis. So similarly you can find moment of inertia for y-axis and moment of inertia for z-axis also. Thus you can work it out by yourself by taking the integrals and using the formula. Okay, so with this I'm winding up your triple integral session here. Thank you for your patient listening. Thank you.